The last organometallic compounds we will look at is the organocopper compounds. We also call it the Gilman reagents. And here is an example, R2CuLi. It's also called lithium dialkyl copper. To prepare organocopper reagent, what we will need is 2 equivalent of a lithium reagent, copper iodide. In ether solution, these two will react to make the lithium dialkyl copper and the lithium iodide. Please note here, the 2 R groups are linked to copper, but typically in the reaction, only one of them will react. The most important reaction for copper reagent is called the coupling reaction. Here is an example. So if you start with an organocopper reagent, the Gilman reagent, and reacted with an alkyl halide, the R groups from the copper reagent and the R group from the alkyl halide will link together to make a new carbon-carbon bond. Okay. We call this a coupling reaction. The 2 R groups are coupled with each other. So here is a specific example. We actually have an allylic iodide and a butyl copper reagent. So the iodide is replaced by one of the alkyl group attached to the copper, and it gives this product. I want you to make a note here. The carbon that iodide is attached to in the product, it's right here, circled by the blue. And the carbon in the copper reagent, circled by red, in the product, it's the carbon linked to the previous carbon. All right, so the carbanion is linked to the carbon that is attached to the halide. Second, in the starting material in the alkyl halide, the double bond is trans. In the product, the stereochemistry is retained. It's still trans. That's actually one of the very important aspects regarding the Gilman reagent coupling reaction. Stereochemistry is retained. Here is one more example. Again, we have an allylic bromide. The Gilman reagent will deliver a methyl group to replace the bromide to give that alkene as the final product. All right. And here's the last reaction I want to mention. Organocopper reagent will react with epoxide in the same way as organolithium and organomagnesium reagents because they are all carbanions. They can be nucleophiles to open the epoxide ring. And please note basic condition. So the less hindered carbon of the epoxide is attacked.